Hey, and welcome to another episode of That Fabric Guy on Microsoft Fabric. And today we are going to speak about partitioning in Delta tables. So what are partitions in a Delta table? As you might know, a Delta table is just a bunch of Parquet files and a Delta transaction log pointing to those files in order to be able to easily query those files. All right, so we have data lake storage with files, and then we have a layer on top, a metadata layer on top called the Delta log that tells the Spark engine how to query the data. Okay, now if you are optimizing for data storage and query efficiency inside the Delta table, you want to be looking at how many Parquet files you have and how large those Parquet files are. Because for the Spark engine to easily read those files, it is optimal to have files that are approximately 300 or 400 megabytes in size in order to not have very many small files that we need to read. That introduces a lot of overhead, and also not to have files that are too large to fit into the Spark cluster's memory. Okay, so the Spark engine itself manages this data. If we start writing a data set of 1 billion rows into a Delta table, the Spark engine will chunk it up into smaller Parquet files. That works brilliantly well. However, if, for example, we want to make sure that we chunk up those files not by whatever Spark decides to divide it, but by a key that we can choose, then we get a nice benefit of partition pruning. So if we partition a table, let's say we have that 1 billion row table and we partition it by region, I don't know, there's a couple of regions, then we get multiple folders inside our Delta table, and those folders contain then one or multiple Parquet files. So now the benefit of that is that we tell the engine how to divide our physical data storage, and that when our queries actually filter on the partition column, we can throw away all the other partitions. We do not need to read and scan those files. We can just jump right into the files that we actually need. So this is a big benefit. However, it is only beneficial on very large tables. Me personally, I try to think of the lower boundary as being 100 million lines or more. Under 100 million, I will probably not look at the partitioning strategy at all. And it also works best when you have a very rigid and predictable query and filter pattern. So if you have a query pattern that evolves over time, or where the filters that you need change quite a lot, then partitioning might be too rigid and you spend a lot of time maintaining your solution rather than benefiting from the performance increases that partitioning can give you. All right, so how do we create partitions then? It's best if I show you that in practice. So let's dive into my laptop and then we'll see how we can create partitions. All right, we're looking at Microsoft Fabric notebook here, and we have created a very small data set, a taxi zone lookup table with only 200 something rows. This is a very small data set that we will be using today to demo partitioning. Why do we do this on a very small data set? That's easy, because we can load that data set while doing the demo. All right, so let's look at the table that we're going to use. This is an open dataset, by the way, delivered by the New York City Taxi and Limousine Company, the NYC TLC. And what we see here is that there is pickup zones that we can find in the different boroughs of New York City. There's 265 rows. And let's chunk those up into partitions by borough. So before we do that, let's see which boroughs there are and how many data there is in those boroughs. And we see there's 69 pickup zones in Queens and in Manhattan as well. And then it goes down from there. Now, having a small table like this, partitioned, doesn't really make sense in practice. Please do not do that. For the demo of today, this actually makes sense. So we're going to create a partitioned table. How do we do that? That's quite simple. We need the delta.tables package, and after we import delta table from there, we can use delta table.create in order to actually create our delta table. So let's do that. We give the delta table a name. In this case, I called it _partitioned. That's not a really nice name for today. It's all right. Then we do add column in order to add the 4 columns of the schema that we need to add, and we use the partitioned by command here, where we tell by which column we actually want to partition. Now this message here means that we actually have created our partition table. Before we start inserting data into our partition table, let's look at the Storage Explorer in order to see what a delta table actually looks like. And then we can see, after we load data into the partition table, how that table physically looks like. So here we are in the Storage Explorer for a Silver Lake house. Let's look at the tables, and we find here that we have a taxi zone lookup table in here, and we see that there is a 7 kilobyte file, a parquet file containing data, and there's a delta log as well. This is to be expected. This is a table that is fairly small. There's no need for multiple parquet files. However, we find tables that are hundreds of millions of lines that have multiple parquet files in order to be right in the 300 megabyte sweet spot. Okay, we're back into Fabric. We will be now inserting data into our partition table. So we do just an insert into, we select all of the data from our taxi zone lookup table, and we insert it into the partition table, and that took about 3 seconds, so that was quite an easy one to do. Now let's look how that physically looks like in our Delta Lake. Let's refresh this to be sure, and then we open the partitioned table, and inside this Delta folder we do not see a parquet file or parquet files, but we do see folders, and the folders now say borough equals Queens or borough equals Staten Island. This means that we have created partitions. We partition by borough, and every distinct value in the borough column now has its own folder, and that folder then contains the actual data. So there's now a parquet file per borough, and there could be many parquet files again. If there's gigabytes of data in a partition, that will probably be divided over multiple parquet files. But in this case, it's a small data set, so we only see this one parquet file. Now what happens when we start querying this table and we need to show all data, we do select all. In that case, we need to open all of these files that are in here, and it's now just a handful, but we need to go through all of the files and have the overhead of opening the files, navigating to them, loading the data into memory, and then combining that data into a single data set to analyze. So that is a downside. If we do not filter by our partition key, then the reading of data actually will be slower. However, when we have a very large data set and we start reading data from a single partition, so we say select some columns where borough is Manhattan, then we can immediately jump to this single folder and only open this parquet file. And that obviously makes our queries a bit faster, because we now don't need to load all of the data into memory and then start searching for the data that we actually need. All right, again, this only makes sense when you have fairly large tables. 100 million lines and up, or 100 gigabytes and up should be the approximate benchmark or rule of thumb to follow. Of course, your mileage may vary, as they say, and you have to figure out what a proper partitioning strategy look like from your end or for your own scenario. However, this is how you can create partitions inside Delta. That's quite easy, as you can see. You just create the table, you add the partition by column or columns. This can be a list of columns, and then you get a partitioned table. Now, looking at the results, there's nothing that is changed in the end result. However, the query that we run here now reads data from multiple parquet files and combines it into the result that we see here on the screen. So, if you like this video, please don't forget to like the video and to subscribe to my channel. I make these videos for free. However, to you, it is not free. That's the gentleman's agreement. You can pay me by subscribing to my channel, so please do so. And I'll see you next time.